about derivatives of sinusoidal functions. So the derivative of sine x is cos x. The derivative of cos x is negative sine x. Okay, so let's determine the derivative of each function. So y prime equals, so cos of 3x. So the derivative of cos is negative sine. So we'll do negative sine 3x, just as it is, right? And then, of course, because this is not just an x, this is a 3x, we have to multiply this by the chain rule. Let's chain rule it, negative 3. So our derivative is negative 3 sine 3x. Okay, x sine x, we can do product rule for this. Okay, y prime equals, remember, u prime v plus uv prime. Derivative first, which is 1 times the second as it is, first as it is, times the derivative of the second, which is cos x. So our derivative is sine x plus x cos x. Okay, y prime equals. So what is the derivative of sine x squared? Well, it's just going to be cos x squared. And then we're going to multiply it by the derivative of x squared, which is 2x. So our derivative is 2x cos x squared. Okay, now we have y equals sine squared x, which is just sine x times sine x. Right? So I'm just going to go product rule. Derivative of the first, which is cos x, times second as it is, plus the first as it is, times the derivative of the second. Okay, what we end up getting is 2 sine x cos x is the derivative. So the derivative of the composite functions, so instead of when we just have like a sine x or cos x, we have sine of a function or cos of a function, we're going to have the derivative is going to equal, well, the derivative of the sine is cos, so cos of that function, and then again chain rule times the derivative of that function. For cos, it's going to be negative sine of that function times the derivative of that function. Okay, so let's try another one. Determine dy by dx. So let's actually use, because the question wants us to use dy by dx, so that's fine, of cos of this function. So what is the derivative of cos? It's negative sine. So let's write negative sine of this function and then multiply it by the derivative of what's in the bracket. Okay, so we get negative 3x squared sine x plus x cubed. That's the derivative. Okay, example 4. Determine y prime for this function. Okay, so we have e to the sine x plus cos x. So we know for e, it's just rewrite it as it is. And then we're going to actually take the derivative of what is in the exponent. So derivative of sine x is negative cos x. Derivative of cos x is just sine x. So I would write it actually backwards. I'd write sine x minus cos x, and then e to the sine x plus cos x. And that's it. Example 5, determine the equation of the tangent to this graph right here at x equals pi by 2. So dy by dx is going to equal, we're going to do product rule. So derivative of the first is 1 times cos 2x plus x, just normally, times the derivative of the second. Derivative of the cos is negative sine 2x, and then we're going to chain rule it with that 2. So our derivative is actually cos 2x minus 2x sine 2x. Now let's sub in dy by dx when x equals pi by 2. So what is cos 2 pi by 2 minus 2 pi by 2 sine 2 pi by 2? So in other words, we're going to solve for cos of pi, and we're going to subtract pi sine of pi. Okay? If you remember from like the special triangles unit in grade 11, or even just graphing these, okay, this is 2 pi, this is pi. So when we talk about sine x, pi is 0. So this goes to 0. Okay, and when we talk about cos, that pi value is -1. So our answer is just -1. So that is our slope. Now, change colors. So I'm going to block this off. Okay, our slope equals -1. Now, what is just simply y equals pi by 2 cos 2 pi by 2? Well, we know that cos of 180 or cos of pi is -1. So we just get pi by 2. Okay, so we're going to try to find the slope of the tangent at pi by 2 comma pi by 2. So pi by 2, y equals mx plus b. M is -1, pi by 2 plus b. This is negative pi by 2, bring it over. We have pi by 2 plus pi by 2 equals b. We just have pi equals b. Therefore, the slope of the tangent is y equals -1x plus pi. Okay, determine the maximum and minimum values of f at x equals cos squared x on the interval 0 to 2 pi. Okay, so let's rewrite f at x as cos x times cos x. Okay, and now I'm going to do product rule. So derivative of the first, which is negative sine x, times the second, minus the first as it is, times the derivative of the second. So we have negative sine x cos x plus sine x cos x. Right, this is, so this is a plus, so we get -2 sine x cos x. Okay, I'm going to show you an alternative way of like doing that derivative. Okay, so if we have cos x, it's basically cos x squared. Okay, bring that 2 down, so f prime at x is going to be 2 cos x, and it's going to be -1 times, what is the derivative of cos x? Negative sine x. So we have -2 sine x cos x. Okay, either way you want to do it, product rule or actually just like the power rule, that's totally fine. Okay, so now when does this equal 0? So when does -2 sine x cos x equal 0? So you can divide both sides by that -2, so that just goes away. Okay, so when does 0 equal sine x or cos x? Well, these are basically factored already, so we want to know when does sine x equal 0 and when does cos x equal 0. Okay, so just to review, sine x again is going to equal 0 at 0, pi, and 2 pi. So x equals 0, pi, 2 pi. And for cos, we're going to equal 0 at pi by 2 and 3 pi by 2. Now, for max and mins, we need to test all of these numbers. We need to test 0, pi, pi by 2, which is good because the pi and pi, or the 0 and pi by 2, sorry, 0 and 2 pi is just the end of the interval. And we have pi by 2 and 3 pi by 2. Okay, when we plug these in, what do we get? Into the original, which is cos squared x. Well, cos of 0 is just 1, so that's just 1. Plug in pi for cos, we get -1, so -1 squared is just 1. when we plug in 2 pi for cos, that's just 1. 1 squared is 1. Okay, pi by 2 for cos is 0 and then 0. Okay, so we're going to have a max of 1 at x equals 0, pi, and 2 pi. And we're going to have a minimum of 0 at x equals pi by 2 and 3 pi by 2.